start recording right
Thank
All
you
right.
so much.
there. I don't know how to give you access to, we'll deal with that later. All right, so then to get to least common multiple, we have 6 and minus 6. Whoops, I have to go back to the screen share now. Sorry. All right, so again, the least common multiple, and so I need 2 and 3. So it'll be CR2S3. All right, let me do a few more.
Yes, please.
You guys, can you just access recorded sessions? I don't know how to do that.
I think that you have to like email
Have
it
to do it?
us or
Okay.
something.
All right, for nickel 2 nitrate is the next one. So nickel 2, if there's a Roman numeral, it's easy because you're told the charge. Nitrate is a polyatomic ion, -1. So we need 1 of these and 2 of these to get to 2 and -2. So it'll be NiNO3, 2. I'm going to go a little faster because I want to make sure we finish on time. All right, ammonium carbonate. Ammonium is a polyatomic ion. Carbonate is also a polyatomic ion, so you know the charges. And again, you know, this polyatomic ion list, I would just have that handy for now. Eventually you want to know it. What you make a few copies, stick one on your bathroom mirror, whatever tricks you do to memorize things. I had someone ask me, should I put it in my car? And I go, not if you're driving with me. All right. So the least common multiple here is a 2. I need 2 of these, and I need 1 of these to get to a 2. So that means it's going to be NH4, 2, CO3. All right, the next one, where'd my cursor go? There it is. The next one is carbon disulfide. I'm gonna write it. Okay, so this, if you go to PowerPoint, carbon and sulfur are both nonmetals, CS. So that means this is a covalent compound. So covalent compounds, you don't have to do any of that stuff with charges. There are covalent bonds, there's no charges. So the name tells you the formula. So you just, the prefix goes carbon. We don't write a mono for the first, but this name is carbon and 2 sulfurs. So it's CS2. Those are the easiest ones to do. I'm gonna do is I'm gonna scroll this. There we go. Okay, same with dinitrogen trioxide. Okay, dinitrogen. And even from the name, you don't even have to look it up to determine if it's covalent. If there's prefixes like this, you pretty much know. All right, dinitrogen is 2 nitrogens. Trioxide, O3. All right, and then the last 2 are acids. So for acids, hey, you know it's an acid because it says acid in the name. That makes it really easy. Acids come in 2 flavors. There are what are called, whoops. Didn't want to do that. There we go. There are what are called binary acids, which have a prefix hydro, and then there are the rest of the acids. And these ones are a little tricky. Acid nomenclature is crazy if you ask me. So hydroiodic, that means it's just hydrogen and iodine. It's going to be H and it's going to be I. Hydro means it's a binary acid. In an acid, you can think of an acid as being an ionic compound where hydrogen is a metal. Because hydrogen's really interesting. It's the only element that can fill or empty its valence with one electron. Hydrogen's one here, right here. It could lose an electron and be 1s0. It can gain an electron and be 1s2. So it can act like a metal. In acids, it's acting like a metal. So if hydrogen was a metal, its charge would be +1. And iodine is right here. So it's going to be a -1. So it'll be HI. Typically, you want to get in the habit of writing AQ for acids. I don't take points off if you don't do it, but my colleagues will when you get to 200. So it's a good idea to get in that habit. Okay, and then the last one going this way, and the other ones are just going backwards. So the slideshow has a lot of slides, but there's internal quizzes, so to speak, where you can go, all right, try some on your own. So that makes it a little longer, but I tried to do a lot of examples in there. So, yeah. Okay, so sulfurous acid is not a binary acid. We do know, though, that it's going to be H+, but how do we find out the counter ion? So if the acid ends in if the ends in ic acid, the ion is the 8. And if the acid is the us acid, then the ion ends in ite. I don't know who came up with this, but that it's weird. So sulfurous means it's sulfite. So sulfite is SO3 2-. And so that means this is going to be H2SO3. So you look at the name will tell you that the ion, again, I would have loved to have been at that meeting because I would have tried to stop them. All right, so that's going forwards. Now we're going to go the other way. So like I said, on the slideshow, the first half of the slides are going forwards. The second half, you should be able to go through it faster because it's the same slides, a lot of them, but it's explaining that you're going the other direction. All right, so now we're going to go from the formula to the name. So if we go BEF2, so we still use the same flow chart. BE is a representative metal. F is a nonmetal, so it's an ionic compound. So all we do is we name the ions. So BE is beryllium. Fluorine is fluoride. And that's it. Beryllium fluoride. That's it. You're done. And my dogs are very happy about that. All right. The next one, KC2H3O2. Again, you look at the periodic. It's obviously ionic because it has a metal and a polyatomic ion. So we go K. What's K? K is potassium. Acetate is a polyatomic ion. Mark out there. Sorry about that. Acetate is a polyatomic ion. So we just call it acetate. Okay. The next one is PBI2. Okay, this one gets tricky. So let me make some space. I have plenty of time on this. So okay, lead. So we know that this is going to be called lead. Lead is right here on your periodic table. So lead can form more than one ion. It is not a representative metal. Representative metals are 1, 2, 13, and then zinc, cadmium, and silver. So that means the name for this is going to be, you have to say the charge. It's going to be lead something iodide. Now to figure out the charge here, you can do the same thing we did before. I'm going to do it up here. We don't know the charge. Iodine, however, we know from the periodic table right here is a -1. We know from the formula that there's 2 iodines. That means there's 2 negative charges. We know from the formula that there's 1 lead, because there's no number written there. We also know that there has to be 2 positives, because if there's 2 negatives, there have to be 2 positives. So that means the lead has to be a +2. So then it's going to be called lead 2 iodide. So the way I show you to get the charge, put the formulas together, you can use the same approach to take them apart. All right. I think I have another one of these. Actually, yeah, okay, now we'll do another one. SnSO4 Let me do that one. Someone was asking me about the crisscross method. This next one's a good example of why the crisscross method doesn't always work. So SnSO4, and I don't teach the crisscross method. All right, but if you've seen that method, this is where it falls apart a little bit. All right, so we know, again, tin is right here. We can't just call it tin sulfate because tin forms more than 1 ion. It's not a representative metal. All right, so this is going to be called tin something. SO4 is a polyatomic ion sulfate.
Do you just put 4 because it has the 4 in it?
Well, the 4 is part of the ion, so no.
Oh.
It does come out to be 4, but that's not why. So polyatomic ions, right? If you look on here, sulfate, that's a good question though. Okay, sulfate, where's sulfate? It's at the bottom. Here it is. Sulfate is SO4. So that 4 has nothing to do with the charges, it's just part of the ion. But if you use this same process, tin, we don't know its charge, but we do know from the formula that there's 1 of them. Sulfate, however, we know is a -2. From the formula, we know that there's 2 of them. That means there's 4 negatives. That means there have to be 4 positives. So that means the tin has to be a +4. See that? If you were doing the crisscross, you might think it's a 2. So that's why you need to be a little bit careful. All right, last couple. I want to get through these. And again, I have office hours, so I'm going to shut this down and I'm going to open it back up at 10 for the office hours. That's just for my bookkeeping. Let me go through the last 3 and then I can still open it up to questions. All right, so NH3, let's do this. If you look at the slides, there's 2 compounds that we use the common names. One of them is water, H2O. NH3 is called ammonia. And so you can just go with that. So you can just memorize. You need to memorize ammonia and water. If you wrote nitrogen trihydride, I would give it to you. But if you said that to a chemist, they would look at you funny. All right, and then the last 2 are HCl.
Professor?
Yeah.
On the polyatomic ions, it says ammonium is NH4.
That's ammonium. So don't
Oh.
confuse it. So yeah, let me address your question. So ammonia, whoops, ending in A, is that ammonium is NH4 with a plus charge.
Oh, okay.
That's ammonium. That's I'm glad you brought that up though. That's a very, did I spell it? God, my brain just stopped. It's O-N-O. I know why I left out like a whole syllable.
Actually, Professor, we have the ammonium in the top when we were writing the formula.
Right. Right. All right. Anyway, okay. And then the last one, HCl. So if you look at your flow chart, HCl is if it begins with H, it's going to be an acid except for water. So then we have to say, is it a binary or is it not binary? Well, there's only 2 elements, right? That means it's binary. So that means you're just going to call it hydro. And then the Cl is chloric acid. And you want to say the word acid. If you don't say acid, it's not an acid. All right, and then the last one is HNO3. Okay, this is not binary. So you look at the ion NO3 is nitrate. So remember, if the ion ends in 8, the acid's going to be the ic acid. So it's going to be nitric acid, which is a particularly nasty acid. There's regulations about how much of it you can store on the 4th floor of a building, which I found out. All right, so that's the worksheet. You have homework 8 due on Wednesday. Again, I broke up the lecture into several, I think like, I don't remember how many, 4 videos or something. That's just because I like to keep the videos, 15 minutes or so. But really spend some time with it. And because, like I said at the very beginning, nomenclature is like a language. And as I said, I'm sure many of you speak more than one language. And you remember when you were learning the second language, you just have to spend time speaking it. And when you're learning a new language, you say, you make some mistakes sometimes. So allow yourself, don't beat yourself up if you make a mistake, just kind of understand what you did, and then you can fix it. And I'm available office hours. And like I said, nomenclature is not going to go away. If you walk into Chemistry 200 and you can do you have a good approach to problem solving, like dimensional analysis, and you can do nomenclature, if you walk in the door and you can do that, you're in pretty good shape. And the mole concept is, in my mind, is part of problem solving. So I think it's really huge, because after this, we're going to do some equation writing, and equations are all going to be in words. So you're going to get a lot of practice with nomenclature there. But on exam 3, if you look at the old exam 3 that's posted, you can see there's a lot of questions. There's just straight nomenclature, but there's also equations that are in words, all sorts of stuff like that. All right, so I can open it up to questions. Otherwise, in about 10 minutes, I'm going to just shut this down for a little bit, because I want to be able to, I want to be able to know who was here for the bookkeeping piece of it, and then I'll open it back up for my office hours. I'm going to stop the recording, and then I have to figure out how to make that available to you guys. I don't know how to do that, but I learned fast.
Thank you so much, Professor.
You're very welcome.